I hope everyone got his t-shirt and we're all good to go. Some folks will start to drink triple in still, but we can get started anyway. So, welcome to Better Assertions with AssertJ. My name is Tim Beek, and I'm a solutions engineer at Modern, where I work on OpenRewrite. Now, some of you may have seen my face before, and then there's a good chance that you saw me speak about OpenRewrite. OpenRewrite is a framework for safe code modifications, which we develop at Modern to allow you to upgrade, secure, and maintain your applications. We're also downstairs here below near the coffee if you want to have a talk to us about that, because OpenRewrite is not the focus for this presentation. I was here last year with a presentation on how we were using AI at Modern, and that drew a very big crowd. For this year, I thought to keep it to a bit of a smaller audience that is much like I am a big fan of code quality and testing. So thanks very much for showing up. It's always great to see at least some folks enthusiastic about this one. Now we'll explore this topic by looking at older testing libraries and then contrasting those with AssertJ. But then you might be asking, who am I to even talk about AssertJ? Well, I'm not a contributor over there, I'm just an enthusiastic user of AssertJ. And I think that everyone should switch to using AssertJ. And I've invested quite some energy into making that both known and making that easier. Because for me, that fits into a larger topic. Whenever I discover a better way to do things, I want to switch to that better way immediately and in full. Not as a best effort that you try to get to over time, not as something that you only do on new projects, not as something that you do maybe if you find the time over the summer or somewhere between Christmas and New Year's, but immediately, everywhere, and consistently. And that focus on improving code quality is also what brought me to OpenRewrite at first, and later on to Modern, to help bring everyone forward through upgrades and migrations to improve code quality at scale. Because for far too long, folks have tolerated using multiple libraries alongside one another that basically do very much the same thing. Given X, I want to verify Y. So I saw this a lot when I was still a consultant a couple of years back, where every project would be using something else. And this would be based on odd preferences, or how old the project was, or who was working on which project, whereas that is not great. Much rather you would standardize on just the one assertion library that you want to use. But for a long time that wasn't possible. Because if you're using Spring or WebMVC and you're using the MockMvc controllers, then for the longest time you were forced to also use Hamcrest for the assertions of what the requests were doing. But now that meant that you would need to use at least two assertion libraries, one to run your tests, JUnit or TestNG, and one for your assertions, which would be Hamcrest, as expounded by the Spring framework. But now finally, with Spring Framework 6.2, we can standardize on just the one assertion library, and I'm here to tell you why that should be AssertJ. But before I can convince you to make the switch, I first need to convince you that you have a problem. And for that, I'm going to show you my IDE. And for that, I need to awkwardly switch screens a bit and try to get this going. Join mirror. Come on. Looks like that worked. So for the most part, this presentation will be going over a sample GitHub repository that I created specifically for this presentation, where I'll be taking you first through some bad examples, then some better practices, then some of my favorite features of AssertJ, and then finally, I'll show you some integrations with MockMvc testing, and also how you can start to enforce these patterns and educate your colleagues and make that automated switch that we're after. So I'll be running through a bit of that as well, and keeping an eye on the time to make it all fit into this block. Now the first anti-pattern that I unfortunately uncovered way too often, and you'll notice that there's nothing for me to click on, and that is when you have absolutely no tests at all. I work in a company where we're making automated code changes. So very often when you make those changes, even though we're very confident in the code that we built, folks love to see at least some tests that verify that what they're changing actually still works after the fact. Now, if you have no tests at all, fortunately there is a solution nowadays. There's a company called debug, which has a product called Cover, which is able to look at your code, look at the gaps that you have in code coverage for your tests, and then synthesize new tests for you to have a bit of a regression suite. It doesn't verify that the code that you have is actually correct, but it does verify that it does exactly what it says it does right now, such that when you make changes, that you are going to be confident that those changes at least didn't change the behavior. So if you have absolutely no tests, remember there is a tool called Cover from debug that is able to at least generate some tests for you to get started. Now beyond that, there's some more add-in patterns, and I'll click through some of these as we go through. So this is the second most problematic pattern that I saw. There should be a different circle in hell for folks to write this side of the code, where if you had no tests at all previously, management would consider, well, we should write a rule that enforces that you have at least 80% test coverage, and then you get things like this. So I won't show you the actual underlying implementation, but all it is what we're doing is we're verifying that we can execute things, and that's where we leave it off. So we're not doing any kind of assertions, we're not hopefully then having to switch between implementations for those assertions, but it is not great when all you have is this. So I can't do very much for you here either, but this is where the folks at debug again can help you at least introduce some kind of verification on what you want to be doing. Now then we have this type of usage. So this is a very portable way of writing your assertions, maybe. It's been in the Java language as of 1.2. But this is where you only use the assert keyword to verify things of a Boolean nature. So this works quite well. Like I said, it's very portable. There's no dependencies. It has some benefits in that sense. But it is also quite odd, because if I run this one, you will find that by default we get an array index out of bounds exception, which is kind of odd because we have some asserts right here. And this is because there is a, you actually have to enable these assert statements before they get executed. So if you just run it in a plain way, or with the very common enable assertions tag that you often get in your IDE, then they will be evaluated, otherwise they get skipped completely. This is perfect if you work in the German automotive industries and you want to always pass your tests regardless of how badly you've built your engine. They call it Volkswagen mode for a reason. But this is, again, not great if you want to do some verifications on the validity of your code. So I'll skip past this one as well. I hope you don't use this too often. Now, going beyond that, there is some patterns that I've seen from time to time where folks use things in a kind of an odd way. So in this case, we have, this came up, I think just last week in our open source Slack, where someone was asking about changes that we're making with a recipe, where in this case, they're asserting that an exception is thrown. They're using already the JUnit 5 way to do so. And then we have a recipe that moves this statement out of this block, because we only want to be asserting on the very last thing. But this is actually very much incorrect. Does anyone know why this is incorrect? And feel free to raise your hand or shout, whatever you think. No takers, which is fine. It's very common to see this pattern, because what we're actually doing here is that we're already catching this one when we call the method boom, and then this one never gets executed. So you'll have some verification. It looks right on first glance, but it takes, in this case, a dedicated audience, and no one will actually raise their hand to see that this is very much wrong. So we have ways to detect this, fix this, and all of that, but this is kind of where you want to be mindful that even if you have assertions, they might not be doing a lot for you. Now, moving on, we have some cases like this one, where folks are using assertions from this case from JUnit 5 already. And then in this case, we can run the test. It passes. It's all fine. But the odd thing here is these assertions are not very expressive. They're not really helping you when anything might go wrong. Because if I run this test that I had disabled, it's going to unhelpfully tell me that you were expecting a collection of 3 elements. It was 4 elements. You have no idea why. And if this is what you get at 3 in the morning on your CI builds, you're not going to be very happy, because you now have to jump into your code, set a breakpoint, run it again, and then only discover what that mystery 4th element was. So again, something that I think can be improved by using a better assertion library here. So then next up we have this one, the list contains, very much similar to what we had previously, where you have a list of 3 elements, you verify that it is true or that it is false by using the list contains. And if it is false, you get the very unhelpful expected true was false. This is probably going to be very recognizable for folks in the room here. You see this a lot. This is not going to be very helpful. And then the problem is that these patterns, they're very established. For a long time, we only had this way of asserting things on like a Boolean nature, but then it's not going to very much help you do things in a better way. Now, beyond that, we have these types of changes where folks might have done their best to upgrade from JUnit 4 to JUnit 5. And a lot of you, I know, have done this with regular expressions. You might have changed your imports only, and if you run this one right now, then it does actually verify correctly. And then if we swap the imports only, we disable this line and enable this line, then suddenly you'll find that your IDE is going to give you a helpful indication, but your compiler does not help you at all. Because right now you're starting to assert that the message that you have is actually null or not null. So this is why we think it's very important that you don't just trust your compiler when you change things, but actually have some further validations built into it when you do so. So this is kind of a I'd say a pitfall when you do those migrations, because we have seen tests where folks are now, like I said, asserting that their message is not null, which is really not doing anything for the validity of your code. So again, anti-patterns that have found their way into code for one reason or another, often through upgrades, and there is good ways to address these still. And then finally, we have this oddity right here, where folks might have upgraded from an older JUnit version or just not really used the correct patterns to do assertions here, where if they are expecting an exception or not expecting an exception, you get these kind of constructs. You have a try catch and an assertion that you and a method that you exercise within that, and then you catch it and then you fail it because you call an exception. This is just plain odd if you know better ways to do these assertions with libraries, and we want to help you find these patterns, replace these patterns, and do this in a better way. Now I hope that you've seen some of these patterns and you now are convinced that you should be doing things in a better way. Now let's take a bit of a look back at how we arrived at these patterns. And with that, I'm going to take you through a number of libraries that have been popular over the past couple of decades, how they came about, what space they operated in, what patterns are still in use from having had those at one time in the past, and what we could now be doing to make improvements here. One of these, I think probably as a raise of hands, who has seen this in the past, let's say, year or so, the test case class that you extend? Oh, that's better than expected. Do you at least recognize it still? Because this one has been outdated since 2006. So if you recognize this, we might have someone in the room here who's younger than the deprecation of this pattern. Very much something you want to move away from, and it is beta of existence, and it's still very much being used. Now, I know we are at a Spring conference, and it's hard to fathom that there is a time in Java where we did not yet have annotations, circa the start of this millennium. But when you wanted to do any kind of assertions at that time, there was a version 3 of JUnit, where you had to extend a test case, and then there were a couple of conventions for you to write your tests. Now, you'll find in this case we didn't have annotations, so we didn't use annotations. So what we then had to use is that any test method should start with the keyword test. And I think a lot of you have kept that pattern going, even though 2006 is almost 19 years ago. Because anytime you generate a new test, your IDE or your AI assistant is going to still propose that you prefix it with the word test, even though we also have an annotation right above it with the word test in there. Kind of silly things, but they are just showing that it's very hard to break these patterns unless you make a focused effort on phasing those out. Also very pervasive is that you had to use public modifiers for your test classes and your test methods, and that has then in turn led to folks reusing code across tests or extending base classes that they have within their organization, very much making it hard to move away from these patterns. And all of this should start to ring a bell like, don't use these patterns and use something else instead. If you didn't name your test correctly, then things would fail here as well. And if we run this one, then you'll see that in this case you get those unhelpful messages again, because the only way that we had to do assertions was to assert that something was true, false, equal or not equal, or the same or not the same. We didn't have much else. We didn't have those ways to verify that it's part of a collection or things like that. All of them not very expressive, and also very limited in giving you more details when things fail. And all of this, like I said, patterns that still exist to the present day. This one I showed you before with the swapping the arguments when you upgrade. Now, moving on a bit then, let's have a quick look at JUnit 4. This one did introduce annotations, so this is very familiar for folks here on how to write these tests. For a long time this has been in use, but this itself, the effort to start JUnit 4 or JUnit 5 was already started 10 years ago. It was released 8 years ago, so if you're still using patterns from JUnit 4, then you're already, again, outdated by almost a decade in these patterns. It also added some test rules that you could add, because they really went all the way with annotations on fields and everything to do these kind of things. Whereas with JUnit 5, they switched to doing these types of assertions, again, with method invocations and lambdas as the language evolved and the framework evolved. Because, like I said, JUnit 4 was first released in 2006. It still used a lot of the patterns from JUnit 3, and but it did bring some of these improvements. Now, circa 2009, some folks started to get the idea on a plane to, I believe, Denmark, if I'm not mistaken, where they wanted to do assertions using a more expressive pattern. And I see that the link is not going where I had expected it to go. I'm going to pull up the sidebar, Hamcrest test. So in this case, they wanted to have a more expressive way for you to say, I'm expecting this and I'm seeing this instead. And for that, they came up with a pattern that allows you to compose these expressions using static methods. So you'll have something like a collection of books coming out of a bundle, and you can say, this is not a null value. Or you can say, has size 3. And when we run these, they will actually work just as well, but when they fail, they actually give you a very helpful, I was expecting a collection with 3 elements, but it was a collection with 2 elements, and these were the elements that were in there. So if I run it this way, where I deliberately introduce a number of those mistakes, then you'll see a better way of doing these assertions. But the way they wrote the framework also comes with some limitations, because you see each of these is a static import, and they can be composed to define something of a sentence, but you also need to know all of the various imports that you need to use here. And this to me is not ideal. It's not very discoverable what all is available, especially when you factor in that some of these static imports might be coming from a different library, like the ones that the folks at Spring have developed, or some other Hamcrest extensions that you have for specific technologies. Needing to memorize all of these is not great, especially when you can combine them. You can maybe copy paste left and right, but it is not very helpful. And if you look closely here, it's also not always clear what you can use when. So I have a collection of books here. I have an assertion that says has an item. And if I run this one for 3 different books, which are each in this collection, then this test passes. But I have another one here, which is very similar, but it uses the static input for contains. You would think, well, has item or contains, they can be used interchangeably. So if I run this one, you will find that no, actually contains is very different from has item. Contains expects to get the complete set of things that is contained in this collection, which, just judging from the name, wasn't very clear to me initially. So what you should be using is pass all 3 of them in this way. So again, while it is an improvement on the failures that you get, it is not very discoverable in how you use this, and it's not very helpful sometimes to know what the correct patterns are to do these types of assertions. So then let's switch back, having seen that one, and then let's look towards JUnit Jupyter. That's been development as of the last 8 years, like I said, the last 10 years in development, last 8 years that we've been able to use it. And this one is actually comes with some more nice ways of writing your test. They no longer have to be publicly visible. They can, even your methods can be packaged private. All things considered, I think that's a nice improvement. But still, it's not very expressive. The ways that you can do your assertions are still using most of those same primitives. Is it equal? Is it true, false, or null? And that, even though things have improved with the assert throws kind of methods, where you move away from annotated fields for your assertions on exceptions to now having a method where you can actually use this one and do these kinds of things and get the return value. All of this is a nice improvement, but it's still not very discoverable in the API that you can use, whereas there are better ways to do this today. And for that, we're going to look at AssertJ. And then this is a test that I have, and like I said, it's all in the GitHub repository, which is using AssertJ already, where you're getting some nice improvements as compared to Hamcrest. You see here that we have pretty much a single import as opposed to a collection of static imports. And we have methods that we can call in succession on this object, and they're all very discoverable. If I open up my IDE suggestions here, you get a lot of options that allow you to find what is available and what you can then write your assertions with. But this is also still using some outdated patterns in how you can be using AssertJ. Because these assertions, they can also be very nicely combined. Whenever you do an assertion, you can also write the next assertion right after it. And that is called chained assertions. And I'm a big fan of using those, because if you compare this one, where you have repeated assertions on the same object, and you compare this one, where you have repeated assertions on the same object, I very much prefer this style of having your assertions defined, because it's very clear that this is always going to be the same element. So know that this is an option. If you're already using AssertJ, then keep an eye out for where you can be using these types of improvements. And then here, very helpfully, like I said, it's very easy to define or to find all the methods that are available for you as for these assertions. And then confusingly here, contains is actually what you need to define that an element is contained within a collection. And it can take one or more books. So there's some things that you need to remember that they're not one-to-one replacements in these things. But this is kind of what I like about having AssertJ. Now another here is, it's a very similar to what you saw in JUnit 5 when asserting exceptions, but here you actually have those chained methods that you can call after asserting that an exception is thrown again. You don't have to awkwardly assign to a variable and then do a new set of assertions on that variable. You actually have this chained way of doing things here. So still, depending on your use of AssertJ, there's things that you can improve, and we'll look towards how to apply those improvements still. Then one last outdated pattern that I want to call out specifically is because I have a lot of through my work at OpenRewrite, exposure to folks that need to upgrade to newer Java versions still. And we also find that a lot of times folks have maybe good reasons why they can't yet move to a newer Java version. But what I then like to suggest is to soften up an organization by first and only migrating your tests to a new Java version. That is possible both with Maven and Gradle and other toolings, where you say, I want to compile my tests on Java 21, 25 even, if you want to go further, where you can leverage improvements in the language already for the tests, verify that your CI will build and all of that without even touching the runtime environment for your applications, if you have a good reason not to do so yet. And then you get things like this, where we're doing assertions on a big string concatenated text block, whereas you could be writing this as an actual text block, even though the main part of this application is still using Java 11, just as an example. So having seen a lot of these outdated patterns, now let's have a look at some better examples instead. I'll take you through some of my favorite features of AssertJ, some things beyond the obvious that you might already know if you've used AssertJ in the past. And for that, we're going to jump to the chained assertions that are very much similar to what I showed you earlier. We saw that unchained version here and the chained version here to allow you to more easily express things that this is all affecting the same object. Now you can also use that when you use the extracting option. So we can do an assert that on, let's say, assert that books dot extracting and then book get title and then contains only or exactly, that's fine, effective Java and all of this. So this is also possible to use that when you want to look at a specific element of that. This is, I think, still fairly standard, but know that it is available because using this pattern is going to be very helpful for you, again, to maybe tag it onto the end of what you already had and then branch off separate assertions there. Yep, all good. Now beyond that, there's one thing that I wasn't even really aware of when I started writing first a blog post attached to this presentation as well as this presentation itself, and that is custom assertion providers that you can use here. You're going to see this later on when we get to MockMvc, but this is a way for you to define new methods that are going to be available to you when you want to write those chained assertions. So in this case, I have a book class which very much unexpectedly has a title, an author, and a publication year. And what I've done is I've wrote a book tester class that I can feed into assert that, and then get access to those individual properties and make further assertions on these. So in this case, I'm just saying that the title should contain effective, but there's a lot more that I could be asserting here, just because we know that it is a string that we are getting back. And this, I think, is very helpful if you have maybe a complex domain where you are very frequently operating on the same return type, and you want to be expressive in the assertions that you're writing, and when they fail, do it in this way. Because if you do it in a different way, where you say book.get title dot contains effective, if this fails, you're going to just say, well, I got some string and it wasn't effective. But in this case, it's going to say, I got a book with a title that didn't contain effective. Again, very much helpful, I think, if you have a complex object where you want to do assertions. And as a library and framework author and maintainer, for me, this is very helpful as well, to know that I can make expressive assertions available to my users just through this pattern. Now, in this case, I want to call out two different ways where I've implemented this, and I'll show the implementation in a bit. Here, I'm giving you back the full freedom of doing any kind of string assertions on the title, like I said, using contains. But you can also say, well, I only want to do exact matches by having a method that has title and then expects the full string, and then allows for chaining. Because at this point, I can do further chains, but they're also only going to chain on the title only. Whereas in this case, I'm doing chains on the book itself, which is somewhat of a difference, but it's good to keep in mind how this is actually done. Now, if we look towards the implementation of the book tester, you'll find that you get a lot out of the box for free with AssertJ by extending that abstract object assert. So this is the class that does some specificer ones for strings or dates, and a lot of types that are available through AssertJ already. But this one is a good base to start with for your complex objects. And then you have a bit of boilerplate where you say, I need a constructor. You have the off method here to get a book tester instance. And then we have those methods that I defined to get new matchers for specific properties of my books. So in this case, I say I have just a regular assert that, the author, described as author, and then give back the abstract string assert for you to define further assertions. So these were the ones that dive deeper into one particular property. Then also I have a trio of methods for exact methods, where I say has author, and then I just reuse that author one to say that it should be equal to this, and then I return myself. This is a field that you get from the higher level abstract object assert, and this then allows you to do chains on the book rather than the title or author or year. So this, I think, is very helpful. There's a bit of boilerplate involved, but it does only give you a lot more expressivity, and like I said, better failures when any of these properties fail to match what you have set out to do. And the way you can hook this in is by implementing this assert provider. This one, it's very interesting. It's not even mentioned in their own AssertJ examples repository that they have. If you look for it, there's nothing there. But this is actually what the folks at Spring have used to allow you to now do assertions using the MockMvc result by implementing in the assert provider. Because what this allows you to do is, if you recall here that we have that assert that, this assert that method is not specialized in any way to handle my books. It's not specialized in any way to handle the MockMvc methods. This just expects that you get something of an assert provider in there, and then from there you get that expressivity of the properties that you can extract and do assertions on. So this is one of my favorite features if you do any, like I said, any complex kind of assertions. Beyond that, there is a few more things that I want to call out. One of them is soft assertions. You've seen me do assertions on a trio of properties of books. Now the problem there is when one of those fails, you will only see the first failure. And there's two ways in AssertJ to actually improve that. So one is to use soft asserts, where you want to say, I want to assert softly all of these different assertions, and then when this try-catch block closes, or try with resources block closes, then I'm going to assert that each of these is true, and otherwise give you a summary of which we're passing and which we're failing. This again is very helpful if you have a complex DTO object with like 30 fields and you want to do assertions on all of them, and you don't want to iteratively go through them if you want to do assertions there. So this is one way to do so. For this I have extended the auto-closable soft assertions class, which allows you to do exactly this. Slight bit of boilerplate again with the title, the author, and the year, but this then allows you to do that type of assertions in this way. But there's a second way that I actually prefer, and that is the setifies option, because this one takes a number of different lambdas, where you say I have assertions on a book, and I want to certify that each of these conditions is actually met. Again, checking different properties in this way and giving you a summary when it actually fails. So when I run this one, you'll see that I get a summary that says something on the lines, well, the title wasn't correct, it was like not ineffective, it was the author didn't contain blank, and the year was not right. So again, I think this is very helpful to know that this pattern exists, because you don't want to be like iteratively going through the failures in your test. So that then is some of my favorite features. Now let's have a look at how you can actually adopt some of these things, because this is actually where my company comes in, and our open source community and some friends of mine also downstairs below, who have actually helped put together a number of recipes for you to automate your migration away from all of these outdated patterns that you're seeing onto what you actually want to be using instead. Now, we don't yet cover everything, so I'm going to show you a bit on how we can extend these rules. But what this will do is it'll run an OpenRewrite recipe. It will try to match all those outdated libraries and frameworks and patterns that you're using. And then collectively on my sample application, it has an estimate of 1 hour of time savings, moving all of this over to AssertJ. And we're going to briefly explore the changes for a bit. Not that one. Come on. That one. And then we're going to see a bit of things that we expect to change here. So earlier on, we saw that we had some. Let me try to see. Is this readable at all? Still? Oh, good. So we saw those problems with the assertion order, where it was incorrect, where we had the messages that were being asserted that they were not null. All of that we can detect and fix. So even if you messed up a manual migration at some point, we're going to fix that for you. Now, earlier I told you that I like those chained assertions with AssertJ. We can detect those, we can collapse those, and make it all work in this way. We saw some unhelpful assertions on collections, where if you are asserting that it contains a certain element, probably you want to switch to using AssertJ collections that it actually contains an element. Because when this one fails, you get a very helpful message, and not I expected, and it didn't, and it was false instead. Same with the collection sizes. There's some things here we could be doing, and like I said, when we then discover after migrating that we can collapse things, we can do that still for you. All, I think, very helpful to allow you to do to switch to what you actually want to be using instead. This one is actually quite interesting. This one is the one where we saw earlier that we've changed things a bit, where no one in that noticed that this verify is never executed. So we're actually improving the test by only asserting on that last element to discover that this boom was actually very early on triggering the halting of the execution in that various lambda. So this is also good chance that if you run this, that you might see 1 or 2 additional failures just because you weren't asserting anything helpful in there. Now, this one I really like, Hamcrest. We remove all of these individual assertions and we go to just the very much same expressivity that we saw with AssertJ, that we saw with Hamcrest, but now one-to-one replacements for using AssertJ. Assert that books is not null value, assert that books is not null. It looks pretty much the same. We can still do a bit of collapsing here on the second run, but this is why I think you should be switching away, because we're making it very easy for you to do so. Now, JUnit 4, still very much same, also all those rules, so you really have no excuse to be using something that was first released in 2006 anymore. Run some recipes, get migrated, and get all of that going. And if you're stuck on Java 8 for your main code, then run our Java 21 migration recipes just on your tests only, and you'll get these types of text blocks. And this is where you can kind of get your manager convinced that no things will not blow up when you start running on Java 17 or 21, and you at the very least get to feel like there has been some development since 2010 by switching to a newer Java version for your tests only. So I hope this gives you some confidence that you can do these changes. And then with that, let's briefly look at the Hamcrest examples that we have here as well. Now, in the old days, if you wanted to do assertions on your controllers, you would have to use this MockMvc. You could do like a standalone setup method. You would get the MockMvc, and then you have, again, this pattern of all kind of static imports to compose your web requests and then do assertions on their outcome. This should look very familiar if you've written these types of tests. And now finally, like I said, with Spring Framework 6.2, they have switched this over to allow you to adopt AssertJ. So keep this in mind, and we'll switch to the alternative instead, which is this one. And then you will see that they look quite similar still. But instead of calling MockMvc perform here, we are now calling assert.that MockMvc.get. And then we have the full expressivity of those chained assertions on exactly what you want to be doing. I always had the hardest time to remember how I would assert on the status or which import I would need, or tweak my IDE to get those static imports available to me the moment that I needed them. Whereas now they just are available through me with a helpful dialog directly in my IDE. And like I said, this uses that same mechanism as you saw me use for books, where you have an assert provider and then an abstract object assert, and that way is how this all works with just a plain AssertJ assert that method for you to now be able to do this. Helpfully, it doesn't have to be a day to night migration, because sometimes folks have invested a lot in doing customizations on either their request builders or their assertions, and for that they allow you to also merge the two styles. So in this case, you'll see that I'm still using MockMvc perform with those static methods to build up my request. This is to support more complex use cases where you maybe had, I don't know, some tokens that you were fudging in there, or headers and things like that, and they really want you to be using the newer versions, so they allow you to use that same request style still, pass it into assert that, and then because that is an assert provider, you'll still be able to use the newer assertion style that you want to be using instead. So patterns that you've seen and learned throughout my presentation available through you here in using the newer MockMvc support in Spring Framework 6.2. Unfortunately, I have to be honest, we don't yet have a recipe for this part. This is where I'm gonna still work on this, but it's just know that all the other parts you can already phase out AssertJ, and you have this to go. So that then is most of what I wanted to show you directly within this repository. But there's a few more things that I can still show you that I think are interesting. And for that, I'm gonna pull up a quick tab here. And one is that there is this AssertJ examples repository. So if you haven't seen enough yet, you want to get a more and better feel of what is available to you, then you can look here to see what else they have. Now some of the examples, they go back a long time. There's but there is good things in there still. One nice thing that I could do, because I have these automation recipes, is that I figured I can run my recipes to improve their examples repository. And that means that all the places where they didn't yet have that cascading style, or they had some outdated assertions, I was able to improve that by running just the recipes you saw me run, and I'm going to recommend that you run as well, to improve the code quality of the docs over there. So if you look at the next iteration, you should be seeing these improvements there. Now, another thing that is quite nice now, and I'll try to pull up not that one, is when you do these types of phase outs as a one big effort and you switch everything over to using AssertJ, then maybe you'll find that you haven't yet changed your colleagues out to now fully use AssertJ. That is very common. So what we have developed is we have a pattern where if you start a pull request and you see that your colleague is still adding something like an assert equals from JUnit 4 or JUnit 5 back in there, that you really want to phase that out. And for the longest time, I would do code reviews and like hammer down the point, no, please don't do that anymore. But then I remember that I can actually do this in an automated fashion as well. So in my sample repository, what I have done is I have hooked up the recipes that I have to migrate you from whatever outdated pattern or not yet optimized AssertJ pattern towards what we want to be using instead. And then we run those on every PR that comes in. This takes about a minute or so, and then what you get in return is you get a code suggestion comment. Let me try to see if I can pull up the details while waiting for it. Where we again run those recipes, and then once this completes, we figure out the diff between where we want you, what we want you to do, and what you should be using instead, and then we post that as a code suggestion from a bot. And then it becomes a one-click button based on this diff to apply those changes to your PR to actually see the changes that you're after. So ideally, in the next minute or so, the next GitHub action that picks up that comment gets run. We're using a Google code suggestor. Sometimes it's off by 1, which is very annoying. But now finally you get this suggestion to move away from the public modifiers and use assert that instead of the assert equals that we had before. So Very helpful pattern, means that I don't do a lot of code reviews anymore because I automate the code reviews that I do. If you want to learn more about that pattern, we wrote a blog to explain you how to do all of this. And then very briefly, I think we started 5 minutes late, I want to show you a bit of how we actually implemented those automations. Because a lot of those are very easy to define. You have one assertion that you want to replace with a different style of assertion. And these are very helpfully implemented in part by friends of ours downstairs here from Picnic, in part by our own OpenRewrite community, and all of them available for you on our GitHub pages and for you to run for free on any kind of code that you have. In this case, you can see the way that we've defined this is we have a before template annotated method, which says find me any kind of abstract string assert, even if it's in like a chained method call. And if your calling is not equal to an empty string, then I want to instead replace it with is not empty. And this is enough for us to figure out any time in your code where you're using those outdated patterns, swap it into place, and do exactly what you should be doing instead. And we have that for string contains as well. We have that for a large collection of assertions, just for you to be able to each and every time automatically use whatever we think is the best way to use AssertJ, and never look back, automate it on your PRs, and never have a discussion anymore. Fully phase out Hamcrest and be done. So that is pretty much what I wanted to show you. If you want to talk about any of this some more, I'll be at the booth that we have downstairs on the bottom left. Let me try to see if I have, yeah, I think I had some more QR codes for you all to scan if you wanted to. Slideshow. So if you wanted to get your hands on the recipe that we have for these migrations, that's the QR on the right. Oh. And then if you want to learn more about any other things, I don't know what this is showing, but then look at these pages. There's the AssertJ docs, the OpenRewrite docs. There's Modern, the company where we allow you to do this at like an enterprise scale. GitHub.com OpenRewrite is where all these recipes live, and then we have a YouTube channel where you can see me do this topic and other topics still. So with that, thank you very much for listening.